A rough inspection, also known as a framing inspection, typically focuses on the structural elements of a building before the walls are closed in. It usually includes structural framing, inspecting the framing for structural integrity, such as beams, joists, and columns. It includes rough plumbing, inspecting the plumbing rough ends, including drains, vents, and water supply lines. It includes rough electrical, inspecting the electrical rough in, including wiring, conduit, and electrical boxes. The items you mentioned, subfeeds pulled to the interior panel and breaker installation, are typically inspected later during a service inspection. This is the inspection of the electrical service entrance equipment, including the meter, panel, and grounding system. A final inspection is done later. This is the inspection of all electrical components, including breakers, receptacles, switches, and lighting fixtures. Inspections are crucial to ensure the safety and code compliance of a building. They help identify potential hazards and ensure that the building meets the required building codes. There could be several reasons why the inspector deferred the inspection. Firstly, safety concerns, meaning the inspector may have noticed other safety issues that need to be addressed before completing the rough inspection. Secondly, incomplete work. The inspector may have determined that the work was not complete enough to conduct a thorough inspection. Thirdly, incorrect information. The inspector may have received incorrect information regarding the scope of the inspection. Fourthly, scheduling conflicts. The inspector may have been unable to schedule a timely inspection for the service or temporary inspection. While inspection fees can be expensive, they are necessary to ensure the safety and quality of your home. Deferring inspections could lead to more costly problems in the future. It's important to communicate with the inspector and explain your concerns. Discuss the scope of the inspection, the reasons for deferring, and possible alternative arrangements. To elaborate on rough electrical inspections, it's important to understand what aspects of the electrical system are typically scrutinized at this stage. The primary goal is to ensure that the initial installation meets safety standards and complies with the National Electrical Code, or NEC. Firstly, wiring methods are assessed. This involves verifying that the correct type and size of wire are used for the intended application. For example, non-metallic sheathed cable, commonly known as Romex, must be properly secured to studs and joists using staples or straps, and it should be protected from physical damage. The spacing of these supports should conform to the NEC requirements, typically every 4.5 feet horizontally and within 12 inches of an electrical box. Furthermore, the proper use of conduit, such as electrical metallic tubing, or IMT, or rigid metal conduit, or RMC, is checked in areas where wiring is exposed or needs additional protection. Secondly, box fill calculations are checked. Electrical boxes must be large enough to accommodate the number and size of conductors, devices like switches and receptacles, and any internal wiring connectors, like wire nuts or crimp connectors. The NEC provides specific rules for calculating box fill based on the volume of the box and the size and number of conductors and devices contained within it. Overfilling boxes can lead to overheating and potential fire hazards, so inspectors pay close attention to these calculations. Thirdly, grounding and bonding are inspected. A proper grounding system is crucial for safety, as it provides a low impedance path for fault current to return to the source, tripping a circuit breaker off fuse and energizing the circuit. The inspector will verify that the grounding electrode conductor, which connects the electrical panel to the grounding electrode, such as a ground rod or water pipe, is correctly sized and installed. Additionally, bonding ensures that all metallic parts of the electrical system, such as conduit, metal boxes, and equipment enclosures, are electrically connected to form a continuous ground path. Fourthly, circuit identification is verified. Each circuit breaker in the electrical panel should be clearly labeled to indicate which outlets, lights, or appliances it serves. This helps in troubleshooting and maintenance, as well as preventing accidental shutdowns of critical equipment. The inspector will typically check that the labeling is accurate and complete. Fifthly, arc fault circuit interrupters, or size, and ground fault circuit interrupters, or GFCIs, are reviewed. In many areas, the NEC requires a size to protect branch circuits supplying outlets in bedrooms, living rooms, and other areas to prevent fires caused by arcing faults. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas to protect against electric shock. The inspector will verify that these devices are installed in the correct locations and that they function properly. Sixthly, wiring connections are assessed. All wiring connections must be made inside approved electrical boxes using appropriate connectors, such as wire nuts, crimp connectors, or terminal screws. The connection should be tight and secure to prevent loose wires, which can cause arcing and overheating. The inspector will look for evidence of improper connections, such as exposed wires or loose terminals. Addressing the reasons for potential inspection deferrals is essential to understand the common issues that can lead to a failed inspection. Firstly, safety concerns are paramount. An inspector may defer an inspection if they observe immediate safety hazards, such as exposed live wires, improper grounding, or overloaded circuits. These issues must be rectified before the inspection can proceed. Secondly, incomplete work can also lead to deferral. If the electrical installation is not sufficiently complete, the inspector may be unable to conduct a thorough evaluation. For example, if wiring is not properly secured, boxes are not installed, or devices are missing, the inspector may defer the inspection until the work is finished. Thirdly, incorrect information can cause problems. If the inspector has inaccurate information about the scope of the project or the electrical system design, they may defer the inspection to clarify the details. This could involve reviewing the electrical plans, consulting with the electrician, or verifying the permit information. Fourthly, scheduling conflicts can sometimes result in deferral. Inspectors often have busy schedules, and if they are unable to allocate sufficient time to complete the inspection properly, they may defer it to a later date. This is especially common during peak construction seasons. Fifthly, code violations are a frequent reason for deferral. If the electrical installation does not comply with the NEC or local electrical codes, the inspector will identify the violations and require them to be corrected before the inspection can be approved. Common code violations include improper wiring methods, inadequate grounding, insufficient box fill, and incorrect use of size and GFCIs. Sixthly, lack of access can impede the inspection process. If the inspector is unable to access certain areas of the electrical system, such as attics, crawl spaces, or enclosed walls, they may defer the inspection until access is provided. It's important to ensure that all areas are accessible and safe for the inspector to enter. Communication with the electrical inspector is key to a successful inspection process. Establishing open and clear lines of communication can help prevent misunderstandings, address concerns, and ensure that the inspection proceeds smoothly. Firstly, pre-inspection communication is essential. Before the inspection, it's a good idea to contact the inspector to discuss the scope of the project, any specific concerns you may have, and the schedule for the inspection. This allows you to clarify any questions and ensure that the inspector is aware of the key aspects of the electrical installation. Secondly, during the inspection, maintain open communication with the inspector. Be available to answer any questions they may have and to provide additional information or documentation as needed. If the inspector identifies any issues or code violations, ask for a clear explanation of the problem and the required corrective actions. Thirdly, post-inspection communication is important for addressing any outstanding issues. If the inspection results in a failed or deferred inspection, the inspector will typically provide a list of deficiencies that need to be corrected. Review this list carefully and ask for clarification on any items that are unclear. Once the corrections have been made, schedule a re-inspection to verify that the issues have been resolved. Fourthly, documentation is an important part of communication. Keep accurate records of all electrical work, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be helpful in addressing any questions or concerns that may arise during the inspection process and can also be valuable for future maintenance and troubleshooting. Fifthly, professional conduct is essential. Treat the electrical inspector with respect and professionalism. Remember that they are there to ensure the safety and code compliance of the electrical installation. Cooperate fully with their requests and provide any assistance they may need to complete their inspection thoroughly. By fostering open communication and maintaining a professional attitude, you can help ensure smooth and successful electrical inspection process. Finally, addressing financial considerations related to electrical inspections is important for managing project costs effectively. While inspection fees can add to the overall expense of a construction or renovation project, they are a necessary investment in safety and code compliance. Firstly, budgeting for inspection fees is crucial. When planning your project, be sure to include an adequate allowance for electrical inspection fees. Contact the local building department or inspection agency to determine the current fee schedule and any additional costs that may apply. Secondly, avoiding re-inspection fees is key to controlling expenses. To minimize the risk of failed inspections and re-inspection fees, ensure that all electrical work is performed by a qualified and licensed electrician. Follow the NEC and local electrical codes carefully, and double-check all wiring connections, grounding, and device installations before the inspection. Thirdly, understanding the value of inspections helps justify the cost. Electrical inspections play a vital role in protecting your property and ensuring the safety of its occupants. By identifying potential hazards and code violations early on, inspections can prevent costly repairs, electrical fires, and other serious problems. Fourthly, consider the long-term savings that can result from proper electrical work. A well-designed and properly installed electrical system can improve energy efficiency, reduce maintenance costs, and increase the value of your property. While inspection fees may seem like an added expense, they can ultimately save you money in the long run. Fifthly, explore options for reducing inspection costs, such as consolidating inspections. In some cases, it may be possible to combine multiple inspections into a single visit, which can reduce the overall cost. Talk to the building department or inspection agency to see if this is an option. By carefully managing inspection fees and prioritizing safety and code compliance, you can ensure that your electrical project is completed successfully and cost-effectively.